is the matrix space with the distance function mod. Correct? Good. So suppose you are having C, complex number. Can you define a function D such that it will satisfy the properties? Suppose your X is C. Can you give me a function?
What, sir? C? Complex?
Complex number, yes.
Sir, is it plain or line? Complex.
This is complex number, complex set. Any number will be A plus Bi form where A and B belongs to R. Yes. The question is, can you give me a D? Say you are having two complex numbers, D of Z comma W. Can you give me something which should satisfy all the three properties? Do you have any guess? I'll give you a little bit a hint. See, whatever you have done for real number case, correct? Can you do the same thing here? But you have some definition of modulus function here. If your Z belongs to complex number, what is mod Z? You have a definition. What is mod Z?
Under root A square plus B square.
Correct. Root of A square plus B square, correct? So can I similarly define here? That means if I want to find distance between Z and W, can I say it is just Z minus W? And the mod is defined like this here. Do you see this will be same as the case of R2 actually? Do you see that? You can put the value of Z and W and see. Is the question clear to you? My question is that whether
Yes, sir.
the set of complex number with the distance function D, whether it is a matrix space or not. Can you quickly check? So this is going to be your homework problem, but I am going to give you some hint. Before going to this proof, you have to see some properties of complex number. Say Z belongs to complex number. What can you say about, there are some properties you can say. Whether mod Z and mod of Z bar, what can you say, the relation between them?
They are equals.
They are equal. Do you agree everyone? Mod Z I have already defined. Don't ask me that what is mod Z here. And what can you say about Z into Z bar? Can you relate it with mod Z? Z into Z bar. Yes? This is, you can take,
mod z square.
exactly, it is equal to mod z square. Third point, if I give you, uh, what do you know about real part of z, whether, and compare real part of z with mod z. Since I can compare only if both are real number, you cannot compare two complex number. I hope that is clear to you. That's why this modulus function came here. You cannot strictly like z is less than w. You cannot compare something like that. There is no comparison between two complex number. So real part of z, this is again a real number, and mod z, this is again a real number. Can you say some relation between them?
Real part is less than or equal to mod z.
What about imaginary part? This
With
is
I or without I?
imaginary part, that means only b, correct? See, if I take z equal
Okay,
to
sir.
a plus bi, this a is my real part, correct? And this b is my imaginary part. Is that clear, Sresh? So whenever
Yes.
I ask about imaginary part, that means I am talking about b. Okay. Mod of zw, whether this is equal to mod z into mod w. These things are quite easy exercise. You can do it at your home. I want you to think. And the next one is whether triangle inequality is true here. That means whether mod of z plus w, if I write, that is less than equal to mod z plus mod w. Because if you prove this all five thing, this question is going to be easy for you. Do you agree? This will be same as this one, as we have done in previous case. Do you agree or not? Can you prove these five things? Can you see the proof?
Sir, the first three are trivial.
Yeah, first three are trivial. What about fourth and fifth one? Fourth is also trivial. You can just put the value and see, because there is no inequality, na? There is equality. So you can prove left hand side and right hand side. You can make it equal. Correct?
Yes.
The main part is the fifth one. Do you have any idea? And I'll just prove the fifth one. Don't worry for you. But I need someone to.
A1, B1,
Yeah.
and A2, B2. So mod of z plus w would be A1 plus A2 to the whole square under root A1 plus A2 the whole square plus B1 plus B2 the whole square.
Yes. I'm just giving
Uh,
you a hint. Try to use the previous results. You are having 1, 2, 3, 4. Try to use them. It will help you, because it will make your life difficult if you put the value a and b and c and d. If you have any idea, just wait for a while. Let me ask with others. Payal, Neha, Ritika, do you have any idea about the fifth one? How to prove this? The hint is you can use the previous property.
Sir, we can take a square of z plus w.
Okay, that seems good. Let us start. So you want me to write z plus w square. What next?
Which is equal to z plus w square, and we are taking a square of that.
No, but that is not equal to z plus
mod
w
z
square.
square plus 2 mod z w
Yeah, but
plus mod w.
do you see, I have already given you a hint, that is you can use the previous one. Do you have anything, something like square? Any property which is having square, something like that?
Z bar.
Yes, exactly, z z bar. So can I write this as z plus w into z plus w bar? Can I do that? But what is z plus w bar? That is same as z bar plus w bar. Do you agree? Yes.
Yes.
Does it seem easy to you now? What should I do next? This will be equal to z into z bar plus w into w bar plus 2. Should I write 2? Let us not first. Let us write like this. Tell me. Z into w bar plus
W bar into Z.
w into z bar, correct? Because I was already having z w bar, w into z bar. Is that okay?
Yes.
Try to see these two things and tell me something. I know something about z into z bar and w into w bar. This is equal to mod z square. This is equal to mod w square. Try to see these two people. This is z w bar plus w z bar. See, what is the main aim? What do you think? In the last, what do you want? Do you have any idea? Mod of z. This is called a trick. You should understand ki, what I want to prove actually at last. Since I am taking square here, so what do I expect here?
Sir, can we write W as W upon mod W?
Why? You are not making it unit
So
something.
it would be Z into W, and we also write Z as Z upon, no sir.
No, no, Shreyas, just wait a while. The question is that what do I want to prove? After this, so many steps, 2, 3 steps, what do I want to end with? What should I write here? Anybody? What was my main aim?
Mod z square plus mod w square plus 2 mod z mod w.
That is exactly same as this one.
Yes.
Correct. So this is what you want to prove. That means what? You are already having two things. These two people I am already having. What extra I require?
2 mod z mod w.
Correct. That means from these two people I want something. How can you do that? Think about it and tell me. Take your time, think about it and tell me.
Sir, can you take the back page
Yes.
where properties are written?
Yeah, sure. Yes. I'll give you a hint. The hint is, what is z plus z bar? The hint is what is z plus z bar. Can you tell me what is z plus z bar? Let us just complete that first. Yes. Ritika,
Yes, sir.
what is z plus z bar? See, if you take z equal to a plus bi, then what is z plus z
2
bar?
times real of z.
Correct, exactly. So this is going to be 2 times real of z. Now this is my hint. Let me see who can think something like that. Let me see. See, this all thing requires your 11th standard knowledge of complex number, because I think it was third chapter of 11th standard where you have done complex number and there were some properties of complex number. If you have done that, then you may think now hint everything is there on the board. You just have to think. Take your time, think, and tell me. Yeah, is there anyone having any idea? Okay, I'll just fill in the blanks. Yeah, yeah, somebody is saying. Who is that?
Sir, W upon mod W, if we write for W, then uh, we can take W out, then Z plus Z upon mod W plus Z bar, then W times Z plus mod W times Z bar, then
See, the thing is that what is my aim? I want to combine these two people, correct? This is my aim. I want to combine these two people and I want to write it as a single unit. Do you agree with my motto? What I want to do? Because in this formula I am having only third term, I am not having two terms, 3 and 4. So the aim was to write these two people together. The hint I have given something like this. Two people I can make something like this. So if you still can, because I have told you everything, I think you should answer that, some of you. Or should I write? Okay, I'll just fill in the blanks. So this is equal to 2 times real of ZW bar. How many of you agree? Raise your hand. Yeah, is there anyone who do not agree with this? Whatever I have written here?
Sir, please explain.
See, I have already given you something hint, that is z plus z bar equal to 2 times real of z, correct? So this is what I am going to use here. Let me just erase it. Yeah. So let us write right hand side is going to be this 2 times real of ZW bar. Okay. So that means what is my Z here? It is going to be ZW bar and this next thing will be ZW bar, ZW bar, the whole bar. Now do you know the property of this bar? I can take it inside actually. Do you know that or not? If you don't know, then you just go home and try
Oh,
to try to do that.
yes, sir.
So this is going to be ZW bar plus this is going to be Z bar W, because W bar, the again bar, it will be W. Do you agree? So that's why I told you, na, if you have done your 11th standard complex analysis properly, then you must have any idea. But I think it is quite long year, so maybe. Do you agree, everyone?
Yes, sir.
Can you complete it now? Everyone, do you agree? Yes?
Yes,
Yes,
sir.
sir.
Good. Can you complete it now? Yes? What next?
The real part of ZW bar is less than or equal to mod of ZW bar.
Exactly, very good. So this thing is less than equal to mod z square plus mod w square plus I can write 2 times mod of zw bar. What next? Not pile, someone else.
Sir,
Not
mod
pile,
of Z.
not pile, someone else. What next?
Mod of Z plus mod of W the whole square.
No, that is not true here. I cannot do that. Someone else. Neha, Neha, Ritika.
Plus 2 mod Z mod W bar.
Exactly, very good. So this is just equal to mod z square. So I am just writing this less than equal to. So plus mod w square plus 2 mod z mod w bar. Do you see I am using all the property which I have already stated here. I am using this property only. So your task will be you have to prove all these property 1 to 4 because I am using all of them. What next? Neha, can you complete it now?
Mod
Neha, I think she is not answering. Is she there? Shreyas?
Yes, sir.
Yes, sir.
Okay, who can complete this? What next?
Sir, mod of W bar is same as mod of W.
Exactly. So mod of W bar is same as mod W. Are we done? Yes, what can I write next? Correct. Do you observe something here? In the case of complex, I didn't have to take any cases. Where in the case of real number, to prove this triangle inequality, I have to take cases. One is positive, one is negative, one is negative, one is positive, like that. Do you see that in the complex? It is quite easy to do, and your next semester, that is in semester 6, your complex analysis, it will be much easier if you understand these things, these techniques. It is going to reduce your task actually. Do you see that within 4 or 5 lines I can prove that the triangle inequality.
Yes, sir.
Good. Now the next part is, I have given you triangle inequality. You have to do this, whether complex number with the metric defined this, whether it is a metric or not, whether it is a metric space or not. Yes, you can write it and send it to me. Since you are only 4 of you, so you can directly send it to me on my WhatsApp number. Is that clear? Is the homework clear?
Yes, sir.
Good.
Yes.
One more part, I am just going to define one more type of metric, then we'll stop. Is that okay? We'll see some more thing later on. That is enough for today. There is one more metric called discrete metric. So again, let X be a non-empty set. Define, say d of xy. I'm going to define it like this: d of x comma y, that is equal to 0 and that is equal to 1. It is going to be 0 if x equal to y, and it is going to be 1 if x is not equal to y. So suppose I am having a set x which is non-empty, and I am defining a metric like this: d of xy, it is 0 when x equal to y, if x is not equal to y, it is 1. Correct? Now my question is that, can you prove this is the matrix? Prove that this d x comma this d is metric. If this d is metric, the metric d is called discrete metric. Okay, these are the two problems for you. You can send me the solution. Yeah, tell me.
Triangle inequality would hold, I think. Quite B.
Yeah, you have to do all the 3 properties and send it to me. Do not answer here. Is that okay?
Okay, sir.
Yeah, you complete these 2 things. One is this, and there was some more thing remaining. I'll send this transcript, the lecture notes I'll send you. Yeah, is the question clear? First thing you have to do is check whether this d is a metric or not, and this will be a metric because I am writing prove that. And this metric is called discrete metric. Do you observe something here? What is so special about this set x along with this metric? If you take any 2 element in the set, the distance between them is always 1. Do you agree?
Yes, sir.
Can you visualize it, everyone? Quite special metric this is, quite special set this is. If you take any 2 element of the set, what I am getting? Any 2 different element, correct? Because if they are same, then it is given that it will be 0. If you take any 2 different element, the distance between them is always going to be 1. That is quite beautiful to see. Maybe I don't know whether you can visualize it or not. Let me just help you a little bit. You will find always the distance between is 1. Distance between is 1 between any 2 element. correct? Something like that. Is it clear?
Sir, this is non-Euclidean space.
Yeah, we'll think about it. See, Euclidean space is only when we are having real number with with normal, that modulus, that is distance, mod of xy is defined, that is called Euclidean space, and other space is non-Euclidean space. We'll come to it later on, don't worry. Let us do not jump, let us do not confuse others, okay? We'll go slow. Is that okay? Is that clear?
Yes, sir.
Okay, great.